Assalamualaikum and a very good day to everyone. For our group project, we are going to present on topic green computing and sustainability. Let's go! These are the members of our group, which are Anis binti Mazuki, Siti Nurul Najwa, Hanis Nabila, Azira Husna and Muhammad Syafiq Haikal.
What is green computing? Green computing, or known as green technology or sustainable computing, is the utilization of environmentally sustainable computing or IT. The most important application of green computing is to reduce the harmful effects on the environment from IT operation by making them more energy efficient and utilization of eco-friendly materials, hence promoting the recyclability of electric components. Where the importance of sustainability within computing is the potential reduction of carbon footprints in technology use, conservation of natural resources, and promotion of responsible electronic waste disposal.
Assalamualaikum warahmatullahi wabarakatuh. My name is Hanis Nabila with matrix number 20231894715. Next, I'll proceed on the topic environmental impact of operating system and computer system. Firstly, for energy consumption in computer systems, energy consumption in desktop, laptops, and servers varies based on their components and usage. Desktops use more power due to higher processing and display needs, while laptops balance efficiency with performance. Servers consume significant energy for continuous operation and network management. Intensive computing tasks like graphics, rendering, or complex algorithms increase energy usage by activating multiple hardware components and sustaining high processor usage. Meanwhile, for operating systems manage energy and resources through power-saving features, task scheduling, and hardware optimization. Updates can improve energy efficiency, but may also introduce inefficiencies that increase energy consumption. Effective OS management is crucial for minimizing energy usage and optimizing system performance. Software bloat refers to the phenomenon where applications contain unnecessary features and inefficient code, leading to larger files and increased resource consumption. This inefficiency not only affects performance but also escalates energy usage, contributing to higher environmental impact. Bloated applications demand more processing power and memory, which can lead to decreased device performance and increased energy consumption. This excess energy usage contributes to higher carbon emissions and environmental footprint. Examples of bloated applications include feature-rich office suites and web browsers like Google Chrome when loaded with extensions and multiple tabs. These applications consume substantial memory and processing power, thereby increasing their energy demands. Electronic waste or e-waste poses significant environmental and health challenges due to its rapid communication and hazardous components. The life cycle of electronics begins with production, involving the extraction of raw materials, manufacturing processes, and assembly into finished products. After their useful life, electronics enter the disposal phase, where improper handling can release toxic substances like lead, mercury, and cadmium into the environment, contaminating soil, water, and air. Globally, e-waste management continues to rise with vast regional disparities in disposal practices and recycling rates. Challenges in e-waste management include insufficient recycling infrastructure, complex recycling processes, and economic disincentive for recycling and reuse efforts. Addressing these challenges requires coordinated effort to promote responsible disposal, enhance recycling capabilities, and minimize the environmental impact of discarded electronics.
Assalamualaikum and hi, my name is Azira Husna and today I'm going to present about the next subtopic, which is reducing carbon footprint through operating system. What is carbon footprint? Carbon footprint is the amount of greenhouse gases that were being emitted by the human activities, be it in a direct way or not. In this context, one of the biggest contributors to the increasing number of carbon footprint is by the data center itself. It is due to their huge energy consumption as they facilitate a huge amount of hardware that requires continuous power and cooling. So, what can be done to reduce the carbon footprint that were being emitted with the help of operating system? Firstly, efficient resource management. This method can be applied by making sure that only necessary components are active at a certain time, so there will be less energy consumption. For example, control the power usage of CPU according to the current process that will be executed. Next is create an energy efficient algorithm. Some example on how it can be implemented are by improving the data retrieval process and prioritize low power tasks. In result, this method will help in saving a lot of energy from various operations, including managing data storage and job scheduling, as the energy is being used as efficiently as possible. And lastly, virtualization and consolidation. Operating system can support workload consolidation by allowing a single physical server to host numerous virtual machines by making the number of physical servers required decreasing. In result, this will help in reducing the greenhouse gases that will be emitted from the data center. That's all from me. Thank you.
Hi, my name is Anis, and right now I am going to propose the sustainable practices in computer system. Now let us take a look at the first proposed, which is to use green cloud computing. We should practice green cloud computing since it delivers scalable IT services over the internet that allow businesses to share and dynamically allocate computer resources, utilizing the cloud scalability and flexibility to optimize environmental advantages. For example, by centralizing IT operations in cloud data centers using cutting-edge virtualization technology, businesses can achieve both economic and environmental benefits by reducing power consumption, cooling requirements, and space needs. Hence, this helps us to eliminate the need for a large physical infrastructure and lowers energy consumption. The next proposed is to practice e-recycling. By recycling electronic waste, we may recover valuable materials and lessen the pollution caused by end-of-life equipment. This helps reduce green emissions by reducing the need to produce new goods and preserve natural resources. With over 2 billion PCs in use globally, energy consumption and fossil fuel combustion has significant negative effects on the environment. Thus, by recovering metals and other resources from all devices and extending the life of IT equipment, recycling e-waste contributes to the development of a circular economy. For instance, we can reduce the need for raw resources by using all device parts for new goods or repairs. Lastly, the power management implication. Practicing power management techniques can greatly improve sustainability by reducing energy consumption and their negative environmental effects. Data centers, which frequently have high energy requirements, can become more energy and space efficient with the use of strategies like virtualization and storage consolidation. One way to lower CPU voltage, reduce heat production, and consume less electricity is to undervolt the CPU, as it is preferable to use less energy and produce less heat. These features are present in AMD's cooled and quiet and Intel step-stack contemporary processors. Therefore, we can greatly improve sustainability with power management techniques and technologies by reducing energy consumption and their environmental impact. Hence, these are the 3 proposals for sustainable practices. That is all from me. Thank you.
Assalamualaikum and hi, my name is Siti Nurul Najwa. I will present to you about the role of operating system in energy efficiency. First, power management features. Operating system or non-SOS has a big impact on managing and reducing energy used through their built-in power management features. These features include sleep modes, which let the device to use less power when they are not being used, which could help to save energy. Hibernation. It turns off the machine or computers but save its current state on the hard drive. All the power management features mentioned above have been implemented or are available in different ways in different operating systems. For example, Windows. User can customize the sleep and hibernation modes to settings more suitable for them depending on their usage. macOS has some inbuilt capabilities like AppNet that significantly reduce battery use by slowing down the background apps not in use. Linux too provide a lot of tools like PowerTop to monitor and manage power usage efficiently. These tools enable the user to determine which programs are using the most energy and take necessary action. These integrated features and tools are vital for portable devices to have longer battery lives and for computer systems to have lower overall energy footprints. Secondly, energy monitoring and reporting. Utilities and tools abound in modern operating systems to track energy usage, very important in identifying and fixing efficiency. For example, Task Manager under Windows, Activity Monitor for macOS, and under Linux. Several applications like PowerTop contain reports of their energy usage. This could provide enough details for the user and system administrators when making decisions to reduce the energy use by providing information on which programs and processes in the system use the most of the energy. This could help the user shut down applications that hog lots of energy by providing real-time data and historical patterns, after which appropriate action can be taken, such as shutting them down or altering their settings. This energy efficiency needs to be maintained, particularly on those fronts where many devices and applications are operating simultaneously. Modern monitoring technology further enable power optimization by allowing energization pattern analysis. Schedule energy-intensive jobs for off-peak hours when there is less load on the system and identify peak use periods from data collected over time. This could potentially significantly reduce cost and energy use of energy. Changing the performance settings in line with usage trends accordingly may also help improve the overall system efficiency. The organization and individual user can utilize such tools provided by the operating system (OS) and make plans to reduce energy use, save costs, and be more environmentally friendly. Lastly, performance optimization. Effective job scheduling and dynamic resource allocation are employed to ensure maximum system performance with the least consumption of energy. For example, operating system can lower the clock speed and voltage of the CPU when the workload on the system reduced. This will reduce the power consumption for low demand operation without affecting their performance. Windows has the System Resource Manager, which dynamically allocates the same resources to application in order to encourage energy efficiency and prevent application from being overly resource intensive while still ensuring they have all they need to function properly. And Linux has completely fair schedule, or known as CFS, effectively and efficiently allocates CPU time between all running tasks, striking a balance between the priorities, hence conserving energy through the effective use of resources. The other important part of performance optimization is efficient task scheduling, which has a huge impact on the energy usage. This scheduling task is to avoid idle time and maximize the usage of resources to help to achieve a minimum total power consumption for a system. This could guarantee that high power states are held only when necessary by rescheduling or merging tasks. This will reduce the power state transition rate, which can be energy intensive. For example, both Windows and Linux use advanced scheduling algorithm in process management for efficient process management. This could ensure the system can maintain its responsiveness and efficiency even under fluctuating workloads, which reduce energy consumption and improve the system performance overall.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Shafi, and now I will continue the presentation of the effectiveness of power management features and proposed improvements and innovations. So first of all, let's talk about the power management features in operating system. So power management features in operating system and computer system have made significant strides in reducing energy consumption and minimizing the environmental impact of IT operations. Through the Advanced Configuration and Power Interface, or ACPI, operating system can control various hardware power-saving functions. This includes actions like hibernating the system, shutting down monitors, or hard drives after periods of inactivity, and also adjust the CPU voltage. This measurement not only decrease the heat generated by the computer but also reduce their energy consumption through technologies such as AMD's Cool and Intel Speed Step have led more energy efficient processing, resulting in lower operational costs and reduced carbon footprint. While we have seen remarkable advancement, there are still room for improvement. One area is dynamic voltage and frequency scaling, or DVFS. This technology could be further optimized to better balance performance and energy consumptions. Currently, many systems rely on predefined power-saving modes that don't always reach the real-time usage patterns of the device. By developing more sophisticated algorithms that adapt to the specific needs of individual applications and workloads, we can enhance the effectiveness of these power-saving measurements. Looking ahead, integrating AI and machine learning can lead to smarter power management. Systems can learn and predict user behavior to optimize energy usage dynamically. In data centers, notorious for their high energy consumption, we can make further improvements. Virtualization and storage consolidation have already helped. By adopting more advanced cooling technologies and energy-efficient hardware design can make a bigger impact. For instance, liquid cooling systems and advanced airflow management techniques can significantly reduce cooling requirements. Additionally, utilizing renewable energy sources like solar and wind power can further diminishing the environmental impact of these facilities. Another crucial step toward better power management is promoting the use of energy-efficient power supplies. Programs like 80 plus 35 power supplies based on their efficiency, encouraging the use of high-efficiency components that reduce heat and waste energy. Expanding these certification programs to cover a broader range of devices can raise the efficiency standards that can drive further improvements. Moreover, providing incentives for manufacturers to produce and consumers to purchase energy-efficient components can accelerate the transition to greener computing. Fostering a culture of sustainability within organizations and among consumers is essential for the long-term success of power management initiatives. Educating users about the benefits of power-saving features and encouraging practices such as shutting down the idle system and utilizing sleep modes can lead to significant energy savings. Organizations can implement company-wide policies that mandate the use of energy-efficient technologies and practices. By combining technological advancement with behavioral changes, we can achieve a substantial reduction in energy consumption with environmental impact. So that's all from me. Thank you.
As a conclusion, green computing is very important for making our computing habits more eco-friendly. Our operating system and computer system eats up a huge amount of energy and produce a lot of electronic waste, both of which hurt the environment. We can reduce the energy consumption through the elegant application of smart resource allocation, better task scheduling, and cool power management features. Things like green computing in the clouds, e-waste recycling, and virtualization set big steps ahead. All these strategies help us save energy, reduce waste, or deal with resources more responsibly, and are hence a key to a greener future. Looking ahead and forward in the future, hopefully green computing will become normal everywhere in the IT world. There is so much that can be done with new technology become visible, coming out with even better energy saving features and even smarter algorithms. If more people come to learn or know how their technology use impacts the planet, then with stronger rules and rewards to be eco-friendly, green computing can spread far and wide. It is a collaborative effort that will reduce carbon footprints in the IT industry today, combat climate change, and leave behind a better place and safer world for future generations. Thank you for watching.